Hi everyone. We are going to start a probability unit here for the next 2 or 3 weeks. To take notes, you may download the PDF attached to the Google Classroom and take notes there, or you may use your notebook. Okay, so an introduction to probability, which you may already know from your past math classes, is probability is always written as favorable over total, meaning the favorable outcomes or the outcomes that you're choosing over the total possibilities. You may write probability as a decimal, fraction, or a percent, and it's always between 0 and 1. I'm sure you can think of many things in your daily life where you see or use probability. Okay, one of the most common ones that we look at every day is weather. Maybe tomorrow there's a 30% chance that it's going to rain, which you may also write that as 30 over 100 or 0.30. So again, there's many ways that you can write probability and that you're going to see probability. Today's lesson just focuses on an introduction. Your homework will look similar, so again, make sure you're taking good notes. That will help you with your assignment. Okay, so number 1, I have 3 examples here, and they want us to answer if the following numbers are valid probabilities. So just a simple true or false. Letter A is 19 over 20. So if you guys take your calculators, and if you type in 19 divided by 20, we want to convert that to a decimal. Okay, so you're going to ask, is 0.95 between 0 and 1? Yes. Okay, because that is between 0 and 1, that is true. That is a valid probability. Letter B is negative 11 over 100. So if you type negative 11 divided by 100 into your calculator, you're going to get negative 0.11. So again, you're going to ask, is that number between 0 and 1? It is not, because it's negative. So that is false. That is not a valid probability. Letter C is 33 divided by 20. So type that into your calculator. You're going to get 1.65. So again, you're going to ask yourself, is that between 0 and 1? It is not. So that is false. And then letter D, we have 1 over 50. So if you take 1 divided by 50 on your calculator, you're going to get 0.02. So again, ask, is that between 0 and 1? Yes. So that is a valid probability. And again, remember, you can write any probability as a decimal, fraction, or percent. So Mrs. Baker and I will accept any of those when we are grading your assignments and quizzes in this unit. All right, number 2, this is something good to discuss before we get into some harder examples. It says, describe these probabilities as certain, very likely, likely, there's an even chance, it's unlikely, very likely, or impossible. Okay, so that we just are going to determine what are the chances that an event could occur based on the numbers that they're giving us. And we'll just go through the first 3 of these. Okay, so letter A is 0.5. Okay, thinking about your numbers, that all probability is between 0 and 1. If you have 0.5, that's right in the middle. So choosing from that list I just read, that just means there is an even chance that that probably could occur because it's right in the middle. Okay, so it might happen, it might not. It's like flipping a coin. The chances of you landing on heads versus tails is going to be 50%. Okay, because it's half and half. There's only 2 options. Letter B is 0. So if I told you that there's a 0% chance it's going to snow tomorrow, what does that mean? Okay, so that means it's not going to, which means the probability of that occurring is impossible. out of that list of choices that we have above. Okay, so B would be impossible, that event is not going to occur at all. Okay, letter C gives us 0.99. Okay, so that is very, very close to 1. Okay, if I said there's a 99% chance that it's going to be sunny tomorrow, well, that's probably going to happen. I would say very likely. I would not put certain because it's not 100%. You still have that 1% chance that it might not occur. Okay, so again, in that list they gave us, I would say very likely for letter C. Okay, we're going to skip skip D, E, and F. Hopefully that A, B, and C was enough to explain that to you. Number 3, I just want to talk about the notation here. So if we zoom in on letter A, you are going to see this a lot in this unit. Okay, the P in front of the parenthesis is just notation for saying and asking us, what is the probability that we're going to roll a fair-sided, 6-sided die and it balances on one corner? Okay, so again, we're not going to answer this, but just so you are aware, when you see a lowercase or a capital P in front of parentheses, whatever's written inside there, that is the probability that we are looking for. Okay, again, just notation that I wanted to cover. I will come back to these examples in a few lessons from today. Okay, so if you have this note page printed out, I would make sure you organize them because I will refer back to this. Okay, I now want to look at, this is the second note page that I had under the PDF of notes for today's lesson. So going with our basic probability, this is applying the definitions and some of that notation that I just showed you. Okay, and your assignment's going to look very similar to this. Okay, numbers 1 through 5 tells us to use the diagram to solve the problems. So we're going to use a spinner. Pay attention to the colors that they're going to ask for. There are also some key words in here that I will review with you. I think you probably remember from last year, but I want to make sure. So number 1, how many pieces are there total in the spinner? So just a basic question to get you set up to find your total. So just take your spinner, go ahead and take a minute, count the different slices or parts that your spinner is made up of. Okay, so hopefully you counted and you wrote down that there are 7 parts to this spinner. Number 2 says if you spin the spinner 1 time, what is the probability that it's going to land on a gray piece? So your notation is going to be capital P or lowercase p, and then in parentheses gray. What's the probability of your spinner landing on gray? So remember, probability is always favorable outcomes over total outcomes. Okay? So the amount of favorable outcomes is how many gray pieces are on the spinner. So if you count that, there are 2 gray pieces on the spinner. Your denominator is your total number of pieces or slices on the spinner. There's a total of 7 pieces. So your solution to number 2 is 2 over 7. Please make sure that these are always completely simplified. I think it's easiest to keep your solution as a fraction most of the time. All right, number 3. If you spin the spinner 1 time, what is the probability that it's going to land on a black piece? So again, let's practice our notation. Probability of black. Okay, it's favorable. I'm going to abbreviate favorable over total. There is 1 piece of our chart that's black, and there's a total of 7 pieces. So your answer for 3 is 1 over 7. Okay, number 4. What is the probability that the spinner is going to land on a white piece? So we are finding probability of white. So if we count up our spinner, 1, 2, 3, 4. There are 4 white pieces. There are a total of 7 on the spinner. Okay, so our solution for 4 is 4 over 7. Okay, number 5 is a little bit different. So it says here, what is the probability of landing on either a white piece or a black piece? So our notation would be probability of white or black. Okay, do you remember what or means in math when it comes to probability? Okay, if anyone will remember, that or means that we need to add these probabilities together. Okay, so we're still using favorable over total when it comes to adding our fractions. So probability of white, 1, 2, 3, 4, if you add up your white pieces on the spinner, there are 4 white slices. There's a total of 7, plus the black pieces, there's 1, and there's a total of 7, okay, which we found these earlier. When you're adding fractions, you may either type them into your calculator. I would put them both in parentheses when you are typing those in. Or if you remember, when you add fractions, you add across the top. Leave the denominator alone. So do not add that denominator. So your solution for 5 would be 5 over 7. Okay, again, make sure it's reduced, but don't add those denominators. You're leaving that 7 alone. Okay, so we will get into more detail with problems like 5, I think next week in our notes. Okay, let's look at numbers 6 through 8. So here's a dice. Okay, it's always going to be a fair-sided dice that they're giving you. Okay, meaning numbers 1 through 6 are on there. So number 6 says if you were to roll the dice one time, what is the probability that it's going to land on a 3? So using our notation, probability of 3, we're still using favorable over total. There are 6 sides to a dice. So 6 goes on the bottom. And think about how many number 3s are on the dice. There is one number 3. Okay, so there is a 1 out of 6 chance of that dice landing on a 3. Okay, so if you ask yourself, okay, is that going to happen? If you convert it to a decimal, that is going to be 16.6 repeating percent. So it's probably unlikely because it's so low, okay, but it's not impossible. So if you think back to our introduction here, you want to always think about what are the chances that this actually could occur. Number 7, if you were to roll the dice one time, what is the probability that it is not going to land on a 2? So pay attention to that keyword not. Okay, we're still finding our favorable over total. Okay, but now we're dealing with probability that it's not going to be a number 2. So you're just going to ask how many numbers on that dice or on that die are not 2s. There are 5 numbers that are not 2s, but there's still a total of 6 numbers on that dice. Okay, so the answer for 7 is 5 over 6. Again, because there's 5 numbers that are not 2s, but there's a total of 6. Okay, number 8. If you were to roll the dice one time, what is the probability of it landing on an even number? So looking at the dice here, okay, the even numbers are 2, 4, and 6. Okay, so our probability of an even number, okay, is still favorable over total. Count up your even numbers. There are 3 even numbers. There are a total of 6 numbers still. Okay, those numbers aren't going anywhere. So here's our first time where you need to reduce this fraction. So write it in simplest form. Remember from when we were in class, to simplify your fraction, use your calculator, type in 3 divided by 6, and then press math, fraction, enter, enter. So it's going to reduce that to 1/2. Okay, I know that one's pretty easy, but when the numbers get larger, that will be helpful to remember. Okay. Okay, one more set of problems that I want to review for this section is anytime you're given shapes or a diagram of something, you can still find probability of the items that they give you. So number 9 is asking how many shapes total are in the array. So take a minute, I want you to count the shapes that are in there. Okay, there's 25. Okay, that's our total that we're using. So make sure you write that back up on our answer sheet, or answer line up here. That's our total we're going to use for 10, 11, and 12. Okay, so number 10, if you were to select one shape at random from the array, what is the probability that it is going to be a circle? All right, so you want to count the number of circles there are, okay, and we're going to keep it over our total, which is 25. So count your circles, 1, 2, 3, 4, 5, 6, 7, 8. So there's a total of 8 circles. And check your calculator, see if 8 divided by 25 can be reduced. Okay, it cannot, so you're going to keep your fraction as 8 over 25. Okay, number 11, if you were to select one shape at random from the array, what shape do you have the greatest probability of selecting? So if they're asking for the greatest probability, again, from the introduction of this lesson, you want to look at what shape is represented most. Okay, so take a couple of seconds. I want you to think about what shape do you think appears most. If you're not sure, if you're between two different items or two different shapes, count them. See which one is larger. Okay, if you were thinking square, that is correct. Okay, the square is on there most often. So your answer for 11, you're going to write is square. Okay, and then the last one is asking us what shape has a 32% chance, which is 8 out of 25, of being selected. So if you look back up at number 10, something should look familiar to you. Okay, good. We already saw that the circle has a 32% chance, or 8 out of 25 chance, of being selected from this array. So your answer for 12 is going to be a circle. Okay, so this ends our first lesson for probability. Again, we're going to spend 2 or 3 weeks on all different types of probabilities, starting off with the basic. If you weren't good at this, just be patient. It will get easier. If you were, things will get a little bit harder, but I think you guys will enjoy it. It's a nice break from algebra. Okay, thank you everyone. Hopefully you guys are all staying safe and healthy.